The next question on deck is number 25, and we're looking at number 25, and basically what you have is a part of the quadratic formula known as the discriminant. Remember that the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. All right, the reason that the square root and what's underneath it, the discriminant, is important is because the only way that you're going to end up with answers like this, plus or minus the square root of 3 over 5, and that's just a for instance. The only way you can get answers like that is if it's not factorable. Okay? You would never be able to factor and somehow end up with that answer. And so, here's the thing. If you've got b squared minus 4ac, and it is a perfect square, then it would have been factorable. You didn't have to use the quadratic formula. So let's talk about the different things. If b squared minus 4ac is greater than 0, first of all, if it's greater than 0, then you can approximate it at a minimum to figure out where it crosses. And so if it's greater than 0, you've got real solutions. Okay? And in fact, you have 2 real solutions. And then from there, if b squared minus 4ac is equal to some value, let's call it some quantity squared, if it's a perfect square, then you should have been able to factor it. Okay? So, equals factorable. Okay, if b squared minus 4ac is not something squared, then the only way to solve was how you did with the quadratic formula, is QF. All right? If b squared minus 4ac is less than 0, that means you're square rooting a negative number, which means you have 2 imaginary solutions. All right. So the question is, though, what if b squared minus 4ac is exactly equal to 0? And let me give you an example. My computer's being mean again. X squared plus 10x. Now let me do something smaller. X squared plus 6x plus 9. Okay. If you do the quadratic formula here, let's just see what happens. So negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So that would be negative 6 plus or minus the square root of 36 minus 36 over 2, which is equal to negative 6 plus or minus 0, because 36 minus 6 equals 0, all over 2. Well, here's the thing. There is no difference between negative 6 plus 0 over 2 and negative 6 minus 0 over 2. Okay? When that happens, and if you want to, I'll just go ahead and tell you that this graph right here is equal to x plus 3 quantity squared. If you had to graph that parent function, it would basically just be the vertex moves from 0, 0 to negative 3, 0. And the thing is, it's called a root of multiplicity. In other words, you get the same answer more than one time. I've always said it's when the but is sitting on the x-axis. what it means is you really only have one answer, one real root. And in this case, it would be negative 3 comma 0. Okay, so whenever the discriminant is equal to 0, it's because the but is sitting on the x-axis, in which case it has only one real root, like this one right here.